Good morning. Welcome to Vegas on a Monday morning. Can't think of anywhere I'd rather be than in this room talking about Edge. Well, maybe I can, but too late. The doors are locked. If you get up now, I will notice. So thank you for joining. I've got to say, it's the first time I've had a Monday morning session this early, so it'll be interesting to see how you all are. I know personally I need a bit more coffee. I'm presuming you do too, but let's try and keep with it and try and stay energetic here, okay? So my name is Alan Renouf. I am a technology product manager at VMware Broadcom, and I work in the software-defined Edge group. Joining me on stage today is the most amazing Ashish Patel. I'll let you do your introductions.
Hi all. Yeah, I'm Ashish, working on as an engineer on this edge compute solution that we are building at VMware, and happy to show what we are building today, as well as listen to you guys how we are helping you to solve these problems.
Thanks, Ashish.
Yeah.
So I'm going to go through some slides today, some reasons as to why the edge exists, some of the things that we've done to solve what we think are the problems at the edge. But really the interesting part, and the reason I love coming to Explore, is to hear from you all about what your problems are at the edge, so that we can make sure that we're on track and that we're kind of aligned with the problems that you see and that we're solving the right things. Because if we're not, we can change our roadmap, right? I mean, that's what we're doing here. And actually you can see that from our product. What you'll see if you look at our release notes of our product is that we're releasing on a monthly basis at the moment. We're getting a new version out there of our product every month. And when people ask me for a roadmap deck, I kind of cringe a little bit, because I kind of show them what I think we have planned for the future. But it's very high level, because what I want to do is make sure that we are talking to as many customers as possible and adjusting that roadmap to solve the most important problems. And I can only do that by talking to you all. So please be vocal, talk to me. If not during this session, during the Q&A, then come and join one of the Meet the Expert sessions. I'll have a list of them all on the screen later on, or you can just search in your Explore app. But yeah, come talk to us. We're super interested to talk to you and understand more about what you're doing. Normal disclaimer slide. I'm sure you're going to see this a lot this week. I'm sure have it memorized by the end of the week and have bad dreams about it when you go home. But this is, normal stuff, especially, as I said, we're releasing on a monthly basis. So this is quite pertinent to understand that that basically anything I show you in this presentation may change, because we are rapidly evolving. So the quick agenda for today is, first of all, talking about what is the edge. Everybody has their own definition of edge. We're going to go through some of those, talk about what we call the edge, talk about what we provide for the edge, who uses it. Hopefully you all use it at the moment, or you have a definition of what you call edge. So we'll see if you're on the screen. If you're not, again, we'd love to hear about what you're doing. We'll talk about what we see as some of the common problems with the edge when it comes to actually kicking off an edge project or even managing edge at thousands of sites. These are kind of the common themes that we've picked up from our conversations with you all. And then we'll give you more information about what you can do this week to continue your learning on the edge and our products, and where you can find us and where you can meet with us. So what is the edge? I did a quick look through the internet and kind of typed out what is the edge, and you get a number of different terms come back. And as you can see, there's a lot of definitions of the edge. And I normally start off my customer meetings by saying, what do you call the edge? Because everybody's definition of the edge is completely different to the next person's definition of the edge. I remember back in the cloud days, it was a very, very similar back in the cloud days, like it's not the cloud days right now, but it still is. But back when we were defining what cloud was, everybody had their own definition of cloud. I feel like it's like that at the moment, where everybody has their own definition of edge, and that's perfectly fine. There's some common attributes and there's some stuff that only you will do, and I think that's absolutely fine. What we're interested in doing is solving the main issues that we see with what you call your edge deployment. Anybody got something that they call the edge that isn't on this screen at the moment? I bet you somebody has. Come on. Shout it out. Go on. Air-gapped, yep, absolutely. Air-gapped edge, I guess that's a good one. We'll certainly be talking about air-gap today and understand the priorities there. It's one of the things that we stay focused on, is air-gapped environments and making sure that we're making the right decisions now when we're designing our product, that they always work in air-gapped. Good one. But what we are here to talk about and the actual area that we work in is the software-defined edge at VMware and Explore. And I like this definition of the software-defined edge. It says a software-defined edge is distributed digital infrastructure for running workloads across dispersed locations, placed close to where endpoints are producing or consuming data. So this is really all about making sure that we are designing a product and creating a product that can be run close to where you are creating data, whether that is looking at sensors, whether that is business critical applications that need to be in a location, whether that is air-gapped environments where you maybe have a laptop in the back of your backpack and you're jumping out of an aeroplane because you're at the edge of a war zone and you need that critical application to run in that location. All of these are kind of definitions of edge, and they are all where the endpoints are producing data at the edge and need to be consumed at that edge no matter what happens. So one of those important areas that's coming up a lot, and I'm sure this isn't the first time you've heard AI mentioned at this conference, and you are going to hear it mentioned a lot more by the end of this week. It's the current word, the current trendy word, I guess. But it is also very important. You know, it's one of those areas where we see a lot of our customers using the latest and the greatest AI technologies to introduce new use cases at the edge. Whether that is something as simple as a computer vision application monitoring a location to make sure that there are no security or safety issues, or whether it's monitoring a manufacturing line to make sure there's no quality issues, or whether it's some more advanced versions of AI, where you're actually taking that model, you're pushing it out to thousands of edges, and you're using your own AI algorithms and applications to make sure that you're delivering these at the edge. AI is certainly an interesting area right now, and it's one where we're seeing a lot of progression and actually, you know, people starting to take another look at the infrastructure that they're deploying at the edge because they now have these use cases and they need more resources and more information. So here at VMware, what we want to do is give you the entire stack that you need to be able to run not just your AI applications, but also all of your other applications that you need to run in those locations. So we want to give you the best edge compute so that you can run VMs, containers, any other types of applications you might have. We want to give you that intelligent overlay and give you those networking capabilities so that you can be able to software define your networking as well and create the network at that location so that when it is available, it can connect to whatever it needs to and provide that data back to a central location so that you can analyze it, so that you can work with it, so that you can make sure that everything's okay. And then the bottom part of this is the Nelco, the network as well, and providing the telco platforms for you to enable this. An easy way to think about this is that it is like a tasty cookie where you can eat each part individually, or you can combine it and you can eat the whole thing and it tastes so much better. So what we are specifically here to talk about in this session right now is the VMware Edge compute stack layer of that area. So what are we doing about infrastructure? What are we doing about applications? How do we get those down there? How do we deploy those? And what are the common issues that we see with those? So you'll see here we're going to be talking about VMware Edge compute stack, and that's that compute part of the infrastructure that we provide. And that is provided to you through VMware Edge Cloud Orchestrator that gives you that unified interface to all of the layers that I showed you a moment, to that entire cookie. So we're going to be talking about the edge optimized runtime, so the part that actually gets deployed at the edge location and allows you to run the virtual machines, the containers, your AI workloads, whatever you need to run at that location. And we're going to talk about how we can make that super easy and the challenges that we see and how we've solved those. So first of all, before we do that, who uses Edge? There's some major areas that we're seeing advance their definition of edge and their deployments at the edge to introduce new applications. By no means is this an exhaustive list of every single place that has an edge. This is more kind of categories of those areas that we see that we are kind of focused on, but the product that we're creating is used in multiple different areas. So manufacturing, I'll show you a picture at the moment about what manufacturing is doing at the edge. Manufacturing is doing some awesome stuff right now, really, taking advantage of that data and those hardware components that have been there for a long time, but they've never, or it's been hard to kind of get hold of that information, to aggregate that information, to update, to work quickly in those areas, and deploy new things fast. So manufacturing's really taking advantage of what we're doing with software-defined edge, being able to deploy those applications, kind of disaggregate the software components from the hardware and move a lot faster to introduce new functionality. Retail as well, super interesting. I'm sure you've all been to one of those stores where you can walk in and you can basically scan your ID card or your badge, and then you just walk around and put whatever you want inside of your cart or your trolley. And then you walk out at the end and it feels like you're stealing something, but really you're not, because the computers and the cameras are in the ceiling and they're watching your every move, making sure that you pick stuff up or put it back again. And then as you go, it charges you for what you purchased. I'm sure you've been in one of those stores. That's one example of what retail is doing. Again, super exciting area of of using edge compute to kind of revolutionize our personal shopping experience. So that's great. Energy, some great things going on inside of energy, really talking about taking that old hardware that they have that's maybe been there for 10 or 20 years and actually upgrading that to the latest version, to using common off-the-shelf hardware now, actually, rather than purpose-built hardware to run some of their applications, to do some of their monitoring, to monitor those power lines and the things that they used to do only through the hardware. And again, revolutionize the speed in which they can deploy and the speed in which they can update and work with these areas. And emergency services. If you were all here last year, you probably saw the emergency services vehicles that we had down in the Solutions Exchange that had the camera on top that was basically using computer vision to analyze license plates, number plates, to know exactly who owned that car and whether there are any issues with that car and whether they need to flag that up. So again, another interesting area. So why do they want to use the edge? Why aren't these just applications inside of the data center? I think it's some of those areas that we spoke about before, right? And certainly some of these areas that we're going to go into in a moment around the data being produced locally. So often there's so much data and you don't really need to transfer all of that data to the cloud because that would take a long time, and you don't need all of that data. You only need the interesting parts of that data. Do I really need an entire camera feed that monitors my location, or do I need to only send me the video clips where somebody was in a secure location when they shouldn't be? So it's really about analyzing that data locally and then sending off the bits that you need to the data center or to the cloud, or even just discarding it and keeping the data, keeping the interesting parts. Poor connectivity, we'll certainly go through this in depth in a moment. Ashish will give you some great demos showing you exactly how we work with that. And then regular.
Alan, if I add one thing over there, so
right.
Sometimes we mix the definition of like a cloud and edge, right? And we try to say, oh, the edge is nothing but a distributed cloud or a small cloud deployed at the edge. But it's not. It has its own challenges. It has its own restrictions. And that's where we're gonna head to today's discussion and showcase like what our solution has unique things to offer. And each industry of this comes with its own things, right? Like sometimes the personals are not there. Sometimes the scale is there, the hardware, there are so many hardwares are there. The speed is limited. The network bandwidth is limited. So all those things are distinguishing the edge from the cloud. So sometimes we cannot take just the cloud construct and try to apply it or break it down and apply it to the edge. Yeah. So that's where it differentiates from the overall our cloud solutions.
Thanks, Ashish.
Yep.
Yep. So, taking a little bit of a deeper dive into just one of those areas, we spoke about manufacturing. And we can see this for everything, right? It's not just about one area that they're trying to improve. It's the entire factory floor and everything that is going on with that factory floor as well. So there's multiple different areas where they're trying to look at providing new applications or new features or new ways of working for that area to provide these functions. And generally, sometimes what we see is that customers are looking at these one by one. So it might be different teams, it might be the same team, but they might be looking at different solutions. So each one of these boxes might be a different solution. So if it's a different solution, then you end up with different hardware. And if it's different hardware, you end up with different operating systems, you end up with different applications, different ways to run those applications. So then this starts to become a management nightmare, not just for manufacturing, but for retail as well. There's a ton of stuff going on in retail, as we spoke about. If you start treating each of these like an individual use case, it starts to become a management nightmare. And this is just one store or one manufacturing line. What happens when I scale out to hundreds or thousands? How do I then start to work with this? How do I provide security updates? How do I monitor it? How do I provision a new store? All of these are where we have started to design a solution that can hopefully work a little bit better. Again, some of those other areas that we see as well is in the energy sector. There's some great stuff going on around oil and gas, power production, monitoring the windmills to make sure that there's no fires with thermal cameras, and then power distribution as well. As I said, we did a lot of work around 3 to 4 years ago, making sure that those workloads that you run on top of our virtualized platform are real-time ready. In other words, they are as close to that bare metal as can possibly be, and sometimes in certain circumstances even faster because of the way that the virtual machines cache their memory and share their memory. But the point is, these real-time applications are now ready to run, whether they are for the power distribution and monitoring the power lines, or whether they're for retail, or whether they're for any other industry that you have. There's no reason why not to virtualize an application now. So some of those common challenges that we see, we've kind of separated our presentation into these common areas, and we'll go through each one of these, talk about what the problems are that we see there, give you some examples, and then we will tell you what we produce and give you demonstrations of our application and how it works in this case. So first of all, scale. Scale is one of those things that's very interesting to me. I started off at VMware working with Power CLI. Is everybody familiar with Power CLI? Yeah, command line interface that allows you to basically automate vSphere, automate the virtual machines, the infrastructure, anything that's inside of that. So I was certainly talking about scale a lot at that point as well, but more scale of the actual virtual infrastructure. How do I deploy 100 virtual machines rather than deploy one? You know, you wouldn't use the GUI for that. You would, unless you like the overtime and like to sit there clicking through the wizard hundreds of times. You would certainly drop down into a command line, run a single command line and deploy 100 virtual machines within seconds. This really, when we talk about scale, automation is your friend and automation is the key here. And that's what we are doing with our product, is basing that around a new wave of automation, a new wave of doing things that kind of takes it out of, puts the control back in VMware and kind of takes the ownership and the maintaining and the creation of this automation back to us. Why would we do that? I mean, that sounds silly, right? What we saw when we were talking to customers is, I remember going into one customer and talking to them about their edge deployments. And I said, well, what's your biggest issues with the edge? And they said, scale. I said, well, what do you mean by that? And they said, well, when we go to deploy a site, this is what it looks like. First of all, we have this 60-page document. We take this 60-page document and we have to pay a service integrator to go and follow that document page by page to set up a new environment. So when the infrastructure arrives, it arrives to our central IT, we power it on, we install ESX, we get it to the point where it has an IP address. The service integrator then VPNs into our network, continues on the configuration of that, and builds out what we call an edge location. And once that edge location is built out, they power it down, we ship it to that edge location, and then we power it on. So first of all, 60-page document. You've got a service integrator in there that they are paying each time that they produce this edge deployment. And it takes them, on average, 3 months to deploy an edge location, to build that edge location up before they can actually get it out there and power it on. Try scaling that to 100 or 1,000 locations. It just doesn't work. You really need to think about things in a different way. So that's why we've started to work on some of the solutions that we have, and Ashish will show you a demonstration of our zero-touch provisioning in a moment. These are often hard-to-reach locations as well. If you're talking about an oil rig, every time you want to deliver a piece of equipment to a location, you've got to jump on a helicopter with the equipment. You've got to fly out to that oil rig. You've got to put it all in, and you've got to power it on. If something goes wrong, where you can't access it via the network, guess what? You've got another helicopter ride back out there. These locations are often really hard to reach, and especially when natural disasters hit as well. So something like a snowstorm, for retail locations. As soon as that snowstorm hits, and that equipment goes down, you might have issues where people can't actually transact or they can't cause issues. Certainly after a period of time, you'll get to the point where you hit those limits and you need that connection back there. So these are in locations that are hard to reach and have regulations for data as well. I know one retail store I was talking to said, after 7 days, we are out of regulation because our prices have changed and we actually need that connectivity back to update those prices. We have no offline way of updating those at the moment. So it's a great example of why that's there. Scaled infrastructure and applications. Obviously, once this is out there, we want to make sure that we are constantly delivering and upgrading and working with these applications, whether it's the latest version of an application that does something different, some new functionality, or whether it's a security update to that application to make sure that we are covered for the latest security vulnerabilities. We want that ongoing pipeline or that ongoing way to update these applications and make sure that they are available and up to date. And not only that, we want to work with multiple teams to do this as well. A lot of the edge locations I work with have multiple internal customers, all work on their own applications, and just want to constantly deliver to a central location. So kind of treat it as that cloud computing that they're used to, where they can go and spin up an instance and then deploy their application and suddenly it's there. But do that at the edge. Make sure it's available at the edge. Make sure that they are in control of updating that application, maybe security patching that application, and bringing it up. And then from the scaled management side of things, as I said before, taking a fresh look at the way all of this comes together and understanding what does my entire edge estate look like? What is out there at the moment? And where are my issues? That's the primary thing I probably want to know, right? Where are my applications down? Where am I having hardware issues? What's not connected? What isn't on the latest version? Give me my current information so that I can firefight and I can solve those issues right now, but allow me to see other stuff as I drill in. So being able to create that platform and that UI that gives you everything that you need for scaled monitoring and configuration of these devices. So with zero-touch provisioning, again, Ashish is going to show you a demonstration of this, but with VMware Edge Cloud Stack, what you're able to do is actually take a box or take 50 boxes and have them delivered directly to site as an edge-ready node. So what that means is that the software is pre-installed, it's ready to go. I can ring my vendor of choice, my hardware vendor of choice, and I can say, hey, I want 50 of these servers. I want you to deliver them to these 50 brand new locations that I want to open up. And then once it's there, somebody will follow some basic instructions to plug the power cable in, plug the network cable in, power it on, and it will come up. It will self-deploy itself. It will zero-touch provision itself, and it will deploy a virtual infrastructure. It will deploy a Kubernetes infrastructure, and it will register itself with the service and say, hey, I'm here, I'm ready to be used. I don't know who owns me right now, but I know I'm an edge server and I'm out here, so somebody please come claim me. So essentially what happens is the infrastructure administrator will go in and say, hey, I know I've got these servers out there, here's their information. When they come online and they contact you, they belong to me. So I will go in there and I will basically claim these servers that are out there, and I'll give them an identity, a profile. I will give them some applications. So I will tell them what I want the virtual infrastructure layer to look like, what I want the applications to be deployed down there, and where to find this information. And then from then on, they will basically keep pulling that location and keep making sure that they are up to date and they have the latest information. You'll see some more of this in the demonstration. It'll show you exactly how we do things with desired state infrastructure and infrastructure as code. Talking about infrastructure as code, really what we're doing here is taking the opportunity to define every part of our edge location as code, whether that is the infrastructure itself, whether that's the hardware configuration, or whether that is the workloads. We are taking each one of those files and we're saying, this is what we want it to look like. We're putting it into a Git repository, because once it's in a Git repository, it enables a bunch of wonderful things for us. It enables, first of all, version control. So we can actually go from version 1 to version 2. If version 2 doesn't work, we can quickly go back to version 1. And then version 1 will be pulled back down. We can make sure that we know what the differences are between version 1 and version 2 and that we're changing the right things. We can see what version 1 looked like a year ago when it was deployed. Now we're on version 596. And we can make sure that we didn't have that security vulnerability that hit at that time. All of these things are wonderful when you start working with Git and things that code developers are used to and work with on a daily basis when they produce these applications. But now we have that in Git. What we can essentially do is create this CI/CD pipeline. So we can create a pipeline that basically says, okay, I see these Git files. What I'm first of all going to do is take them. I'm going to deploy them on some virtual infrastructure, a virtual version of this edge compute stack host. I'm going to spin that up. I'm going to make sure that the hardware is configured the way it should be. I'm going to make sure the infrastructure is configured the way it should be. I'm going to make sure these applications get deployed. I'm going to run some tests against those applications. I'm going to make sure they look good. And at that point, we can be kind of, okay, we're happy with the changes that we made. It's ready to go out to those edge locations. And as I said, each of those edge locations is configured to read that Git repository and understand what it needs to pull down. So it's the one pulling that data down on a scheduled basis, and it will see that version of these files. It will download it. It will download the applications, and it will stand up those applications so that they're ready to go. There's multiple ways in which you can configure your Git configuration. You can go from something as simple as a single site for a single host, excuse me, where you configure everything in one Git repository, or you could go down the point where you actually start to get complex with these and you have multiple Git repositories, multiple levels of ownership where maybe the infrastructure team puts the infrastructure changes into one YAML file, each individual application team puts their own changes into their own Git repository. All of this ends up with a single source of truth that is a combination of all of these so that it gets deployed out. You could even put the company basic information in there as well to make sure that every application that's pushed out there is monitored the same way or security checked in the same way. So, really take those standards down as well. This is really, down to you as to how you want it configured. We've got some great blog posts and documentation on ways that we can show you how to do this. But, the world is your oyster. You define how you want it to work, and then you essentially deploy this out to the edge. Some of the examples of what this looks like. Containerized applications, you should see no difference here if you're used to Kubernetes applications. There's absolutely no difference in the YAML manifest. We essentially take that YAML manifest, we push it to the Kubernetes API, and we allow it to stand up in that location. And we've got multiple examples in our Git repository. We have an example Git repository of some kind of standard computer vision applications or other applications that you can check out. Virtual machines, we now define it in exactly the same way as those containers as well. So you open up a YAML file, you define how you want your virtual machines to be deployed. You basically say, hey, I've got this OVA, here's the location, go deploy it. I want it powered on. I want to add a pass-through to this GPU, or I want to enable low latency sensitivity so that it's a real-time application. So all of these things you will basically enable within the YAML file, and then once it's deployed, those VMs will spin up at each of these locations, whether it's one or whether it's thousands, it will spin up at each of these locations as that file is pulled. You can even deploy images straight from the Bitnami catalog as well. There's a whole host of OVAs in the Bitnami catalog, so you can define that URL straight in there and pull those down and deploy those as well. When it comes to the Kubernetes applications, we have a way for you to configure the default worker node. So by default, we ship a worker node that those containers will come down and they will get deployed on. But if you have your own opinions, your own worker node that you want to deploy out there, you can certainly customize that. Maybe you want a real-time operating system that runs those Kubernetes applications. You can basically replace our default worker node, and you can define the amount of memory or the CPUs that you want to give to it. So I've been through a lot of these solutions. For time, I'm going to move over to Ashish, who's going to give you a demo on some of these solutions, and give you a break from me talking and also a PowerPoint. So Ashish, I will hand over to you.
Okay. Thanks, Alan. It was really, really good in-depth introduction about the different challenge. The first challenge, that was the scale, right? And let's look at it how ECS as a solution is trying to handle this one. So first part, I want to walk you through, guys, from zero trust provisioning. So, yep. So when you come to the ECS service UI, right, we provide a 3 different variant of ECS host image. You can download it as a ISO file, OVA file, or IMG file. ISO, you can mount it as a CD-ROM. OVA, you can deploy it on a virtual appliance like ES. Or you can even use a IMG file and burn it as a bootable USB stick and use it for deploying or booting up your hardware, right? So here we are downloading the ISO file, and so I have this hardware where I'm going to mount this one as a CD-ROM. Yep. Choosing the file. And here we are mounting this ECS host image as a CD-ROM. And now I'm going to change the boot priority to boot the device from my generic CD-ROM. So, yep, let's change the boot device to boot the hardware from the generic OS. Okay, so here you can see it is installing the ECS host image on a hardware. It may take a couple minutes and your hardware will be ready. And once the hardware is ready, our ECS host is installed, you will see this information which points to your, like, what is the make, model, and serial number of your hardware. Plus, it also generates a unique activation key, and it also provides some information like ECS host version, right? We have to record this information because we'll need this one in registering the product with our ECS. So let's go back to the ECS service. Now comes the interesting part. We have to first configure the Git repository. So we have this demo repository already up with computer vision app as a Docker container workload, and we have a WordPress app. So here I have this example app which will be deployed as a Kubernetes workload. I have this WordPress app which is a Bitnami WordPress VM. That will be deployed as a virtual machine. So we want to just demonstrate that on this infrastructure you can deploy container workload as well as VM workload seamlessly, right? We copy this URL, and here you can specify the default branch that you want to use for deploying the Git repository, right? So this is the Git repository configuration. The next thing you're going to do is configuring the sites, right? So the site is more like a logical grouping of the host based on their physical characteristics, like what their location is. Or even you can say, okay, these hosts are based on like some hardware characteristics. So you can combine them based on that. As of now, let's say we are in Las Vegas, we want to create an edge site for Las Vegas. And so here we're going to select the Git repository that you have added. Here you have opportunity to either point to the different branch or different path. So you can have like a release 1.0, release or pre-release branch. You can point to try it out if it is deploying from that branch, right? You want to just, before even rolling out to all the edges, if you want to have a testing site, you can have a pre-dev branch, you can specify it over here, and that site will only get that particular Git version. You have to specify the username and access token. The access token doesn't need any write permission. So you can have a read-only access token configured over here. The site is added. Then we have to go and add the host over here. So when we are adding a host, there are two ways to add a add host, means registering the host with our ECS solution. One, using the hardware information. Second is using the activation key. So hardware information could be like a make, model, and serial number, or you can use the activation key. So sometimes if you are using a low-cost, non-standard hardware for your testing or lab and other infrastructure, you can, and they may have like a common strings like default, right? And then it's very hard to identify the hardware as a unique hardware. You can use the activation key. So here I'm going to use the activation key for registering the host, and the activation key we got it from the screen that we got when we created the host, right? So that's all. I'm going to select the site that it belongs to, and here either you can inherit the setting, Git repository settings from the site, or you can say, oh, this is my one-off node. I want to configure a very particular Git repository or version or path for this particular host. And here I'm going to select a site, inherit from the site. The host is registered. Now the host that you have deployed, either in your lab or at the site, it continues reaching out to ECS service and said, please enroll me, right? So as soon as the ECS solution detects that enrollment request, it moves the host from registered to the not active. Not active means is registered but yet not activated. And after that, you can manually activate the host. Once it is activated, the ECS solution starts sending the Git configuration, your labels, etc., into to the host, and then it moves the host into the active state. At that point, your host is basically configured, basically, right? And then the host start deploying your workload, VM, whatever configuration that you have provided into your Git repository. Back to you, Alan.
Thanks. Yeah, so she showed you a demonstration of what that looks like when it comes to a single host and how you would start off and set these sites up. Obviously, once you've got that site set up, you could add hundreds, thousands to that location and define your YAML files in such a way that they all get the same configuration, common applications that are pushed down there. The next area we wanted to talk about was limited networks. It's another area that we see that is a differentiator when it comes to the edge. I'm sure many of you are used to working around these kind of these issues that you see on the screen. So we're talking about things like you don't always have the best network connectivity at an edge location. So you need to be sure that what you're pulling over that data or that WAN link, or what you're pushing up through that WAN link, is the most important information at the most important times, and that cannot be used by other things during busy times. You need to make sure that you understand that periods of disconnection are expected. So design for that. Make sure that you understand that if you have everything ready to run at that location, it should stay continuing to run, even if that connection to the internet is not there. So we have a way to basically enable you to do that for most of the workloads. And design for, completely offline as well. Somebody mentioned air-gapped earlier, making sure that you, in those environments, have a way to almost sideload updates into that equipment that may not ever get a connection. Maybe it's on a submarine, maybe it's somewhere else that has no connection for a long period of time, but you still want to get an update out there to an application or to some information or security update it. And making sure that we design for things like impacting business operations. As I said before, you are the people that know when your busy periods are for that edge location, when you want the updates to happen, when it is not okay for an application to be offline or the infrastructure to be offline, and when it's not okay for you to use that WAN link to make sure that we don't download updates and patches, things like that. So one of the major differences between what we've produced with VMware Edge Compute Stack versus what you're used to with a data center deployment of a vSphere environment is that, as we've discussed, everything is pooled by that host. So those hosts get deployed out there to the locations. They're the ones that actually reach out to that central location and pull the information that it needs. And then it keeps it local so that if that network connection gets cut, it knows I've got these desired state configuration files, I've got these applications. If I go down and I come back up, I still know exactly what I need to look like because I've got this reference. I can just bring everything back up again. All the workloads will continue to run to continue to make sure that they still work. Whether that's in, as we mentioned, whether that's an offline environment at the edge of a war zone where, you've jumped out of an airplane and powered on the server and now you need those applications to come up. There's no need to reference that central, to push any data to that location. It's all pulled from that host. So this really makes the infrastructure work in a great way. All the decisions are made locally. The control plane is local. So for those solutions that we've created, we make sure that data is always pooled, the updates are delivered locally, and then basically applied at a time when you want. We are designing the way that you can schedule updates or that you can limit the bandwidth used by those updates as they are pulled down. If you're interested in those areas, I'd love to talk to you more during the conference to get your opinion on the way that these things should work or validate some of the thinking that we have. And we want to make sure that obviously once those servers do go down and when they come back up, that everything is brought back up so that those business operations can continue even if there is no connection.
Yep.
So I will hand over to Ashish again, that's going to give you a demonstration on what that looks like.
Okay. So this is for a limited network availability. Sometimes what happens that at the edge site, the network, there's a network outage, and you cannot push your code there, right? Let's say I have connecting to cloud. If I'm running any CLI commands I need to constantly have connectivity there. Here, our approach is a little bit different. Here we said, okay, you put your changes, everything in your desired state the way you want, and let Edge be responsible for pulling the changes whenever the network connectivity is back, and it's ready to take those changes, right? So for the start, to simulate the scenario of having a network outage, right now I'm going to just disable the customized controller. That is actually responsible for pulling and reconciling the changes, right? So I'm suspending the customization controller, and let me just go ahead and change the Git repository, right? So I'm changing my VM WordPress to be like a WordPress updated over here. So I renamed it. Let's see how is it really picking up my changes or not, right? So if you log into the ECS, you will see that the changes are not yet picked up because there is no connectivity as upward connectivity to the central Git repository as of now. But your app still continues running on the local device. It is not broken yet, right? Your older version continue running. Your system is still working as it's expected. Now let me resume the customization service. Now, what I'm expecting is that it should pick up my Git repository changes as soon as possible. As you can see, as soon as the connectivity is up, it has picked up the changes and started deploying the new VM, get rid of the old VM. And it's got a new IP address also, like 172.82 instead of 125. And the app is running on a newer. So this would be like, you don't have to constantly monitor your network connectivity, right? I mean, there are network connectivity is up. Now I have to press a button versus network connectivity is out. I have to wait for a couple of minutes and that. Here you commit the changes and let Edge be responsible for pulling the data whenever the connectivity resumes. Yep.
Okay, I know we're running short on time, so I'm going to speed things up very quickly. Edge hardware protocols and considerations. We know the hardware being used at the edge is different to the hardware being used at the data center sometimes. We are making sure that we do everything that we can to support that. If there is some edge hardware that you don't have on the HCL at the moment, we would love to talk to you and understand what that is so that we can make sure that we are working with those vendors to support that edge hardware. You can already see too at the top right where we have certified a Siemens BX39A for use. This is an industrial PC. So essentially we've certified that for use with VMware products. We're working on a Contron K-Box at the moment. These are common servers that we've spoken to our customers about. But again, certainly interested in the edge boxes that you want to use, the type of hardware that you want to use. We know it is different to the data center. We know it is often a lot smaller and more cost effective to be deployed at hundreds of locations, thousands of locations. Protocols as well. We know the protocols that you're using at those locations, especially for things like manufacturing or energy. You have your own protocols that you want to work that are not necessarily supported at the moment. We're working together with not only VMware, but also PLC vendors to make sure that we are supporting the correct protocols that are needed at those locations, whether it is something as simple as MQTT or Parallel Redundancy Protocol, PTP, Profinet. All of these are being developed right now in a low latency switch to make sure that they work correctly when they are at those locations. No demo on this one. If you want to see a demo, go down to the software-defined edge location where you can actually see a physical demo running, where you'll see a mini manufacturing line running with a computer vision application running next to it, all on edge compute stack. So you can see the physical demo and ask more questions about how that works and what that looks like. When it comes to limited on-site personnel and security, we know that you don't have an IT person sat there at every location waiting for something to go wrong. It's more of a centralized IT that gets called if something does go wrong, and it's normally the location that knows something's gone wrong before we ourselves do in supporting those locations. So what we want to do is make sure that we provide as much information and as much capability to you to provide support and monitoring of these locations for these edge sites. Things like being able to remotely reboot, being able to provide break glass support, local monitoring, all of these areas we're looking at the moment, if not provided. And Ashish, I have a feeling we don't have time for this demo because we're already over time. I'm sorry. If you want to see the demo, we can certainly spend some more time later. I am correct in saying we're over time now, right? Right. So I'm sorry, it's a great demonstration.
Everything is good. Yeah, but just a thing, like we do have a different aspect that Alan talked about, like monitoring solution, how you can remotely monitor your edge. All those things, all the different aspects are covered. We will be happy to show you in either Meet the Expert or at the booth.
Yeah. 11 o'clock today, there is a Meet the Expert session. I think it's
at the bottom
on here somewhere. Basically, which one is it? It's on here. Oh, over on the right. Sorry, 2430. If you search your catalog, I know it says full in there, but honestly, a lot of people don't turn up. I would just walk up there and come sit down and check in. It's just going to be me sat there twiddling my thumbs unless you come along and talk to me about interesting things. So I would much prefer that you came along and spoke to us. I'll make sure Ashish is there. We can even give you the demonstrations that we didn't give you right now. We would love for you to come along. There's a lot of great sessions going on. Talking about more in depth of what we've done here. Make sure you go to the Software Defined Edge Expo area and we will answer any questions that you have and would love to get in contact with you. I think it's pretty obvious what we've shown you so far and how we are designing our product for the edge. As I said, the most important thing is for us to get feedback from you and to work with you on what your edge looks like and how we can make sure that we produce the best product possible in VMware Edge Compute Stack. Please take the survey and we would love to talk to you. Any quick questions? Please do use the mic. Anything that I can answer? Nope. Okay. Sorry, the last part of that was a bit rushed. I guess I was a bit too verbal at the start. Yep. Reach out to us. We're here to answer questions. I'm here all week, folks. We would love to talk to you. Thank you very much for your time.
Thanks all.